breaches in this levee, but there's this natural levee. And what that happens is when the river floods, it floods up and it can go onto those fields in very, very large storms, maybe 100-year storms. And what happens is the coarser material over years, hundreds and hundreds of years, drops out very quickly because it's heavy. The finer stuff gets washed off into the field and what creates good soil. But over time, and it's happening again and again, we get this natural levee being built up. And I'm only mentioning this because this is something that it's complicating, and therefore it has to make sure that we put our monitoring in the right place to measure the right thing. So one thing that tells me is that that levee's there. Well, if water runs into that field, it's got to go somewhere, and what's probably happening is going down. So we've got to be somehow measuring water moving through the soil and into the soil, and what happens as it moves through the soil. So this gives you an idea. This is a picture of field 12, and what's actually happening, water's going this way, and again, it's happened over, it's a natural process that's caused this, and it's moving laterally along here. So that gives you an idea of some of the surface flow. I won't belabor it, but so I'll go on to now the ground penetrating radar information results that we got from NRCS. We haven't completed that yet. We got stuck or delayed by storm, and we also we got permission to be on these fields, like I say, but the one caveat to being on those fields was not to mess them up, not to create rugged divots and tractor, by pulling our equipment. So we've got to work with the landowners to not mess up those, those fields, and so we need to be cognizant of making sure that we're there and respecting those landowners, and so we go out there when it's really drier. Obviously, we're not going to create a lot of damage, and we're not going to create compaction with our equipment, which could then cause a problem that wasn't there in the first place. So this is the ground penetrating radar. This is field 1, which again was a steep slope. It has a permit. It's going to be able to fly to this field eventually. Hasn't yet. And so the survey looks at this ground penetrating. We did NRCS took 2 surveys across field and downfield. This is one of the team members. We've been up to work. This is Professor Chris Bride. You might recognise the backside of him. And this is Richard Paul with NRCS out of Little Rock, who has been very gracious in helping us, because part of what he enjoys doing is this ground penetrating. So you drag this thing along, and it sends these radar, and it bounces back echoes. But what it gets you is this pattern, and it looks, it's a bit messy, but he can interpret this, and we can also go back with a more sophisticated or more resolution. Maybe this was the first step, but it shows some discontinuities. It shows that there may be some dissolution features there because of this pattern. As I say, I'm not the NRCS, the expert in doing this and also in interpreting this. So it shows what's below there. One of the things we see, it's got this on inches there, it's about 3 to 4 feet down. So there are what we see there as karst features. We know it is karst. But the other thing is, we do have this topsoil at the top there, because the river's flooded and deposited this alluvial soil. So we've got a mixed situation, obviously. And then this is the other survey going the opposite way. Same sort of thing. We've got this A horizon, and then we've got this very, very discontinuous underlayer there, which is kind of going all over the place, which is, again, karst. But we know it's karst, so it's good that this equipment picked that up. It should be there. This is field 5, same thing. He conducted these surveys. Again, this is on field 5. And you can sort of make out what he is assuming. We'll go back, we can probably do, we did do some coring at the same time to get some cores, to get some ground truthing of these radar. The radar is non-invasive, but we can do some invasive sampling to make sure that this is what it is. But that's maybe gravel lenses. We know they exist. And there's a marked increase in clay content. Maybe that's a large flood hundreds of years ago deposited a lot of sediment from upstream. So this is the sort of thing that we're learning underneath, gravel ledges again. But I think one thing it shows that they look nice green flat pastures from when you're standing there, but obviously below the surface it's quite complicated. And so moving on from that, we've got that information. That's guiding us then to determine what to monitor and where to monitor it based on that. This is the 3 fields that we have, again, permission, that we do have written permission to be on from the local landowners. And we did a grid sampling, and it's 0.25 acres, may not be the scale exactly, 0.25 acre grid. This is much more intensive than a nutrient management planner would do, collecting samples of field, but we want to get an idea of how variable it is processed. So on this grid, we collected samples down to as far as we could go. Sometimes we got down to about 3 feet, sometimes we could get down to 6 feet. And so we've analyzed those, phosphorus, nitrogen, different calcium, all sorts of things that we can measure from those soil samples. We got those done at the State Soil Test Lab down in Mariana. So what are soil samples? And we've done 5 and 12. 1 and 5, is that right, Mike?
Yes.
1 and 5. The technicians had to have a break because field 1 was very rocky, and it's not, as when you do field work, those that do it understand that it's a lot easier looking at it than actually doing it. It's hard. It is hard work. If the rock's there, you'll find it. But this is the type of information. We have a Giddings probe, and it basically pushes down with an ETR the probe into the ground, and it does do some compaction. So again, we need to do this when it's dry for the landowner's sake. And so this is what we find. We've got a bunch of data. It's in the quarterly report. You can go online and look at it, but this is just a general representation. And it shows it's quite variable. The average value across that field is fairly similar. It's a little bit lower what we found from this grid sampling than what the planner had in his plan. That doesn't really mean anything other than the fact that we took a lot of samples and averaged that, but it shows there's a lot of variability. We obviously showed this to the farmer, and he wasn't surprised. The red part there, it goes from, as you can see, the grey is the lowest. This is what we call malic phosphorus, which is our state soil test. It determines plant availability, plant requirements. About the cutoff is around about here, around there. That, you don't need much water. But it shows us the red area there, and that's his feeding area. That's where that landowner's putting his hay out, and the cattle congregate to eat. And they do what the cattle normally do, or what we normally do when we've eaten. So that's why it's a little redder there. The one good point about that is it's not right next to the creek. So this is something the farmers know, the farmers do all the time, because they know and understand their land better than any of us researchers, that you can move cattle around and move those nutrients around the farm by where you feed them. But this is the type of information that we get from this. We know that there's what we might call as a hot spot there, red, where that is, and that's, as I say, in this case, is near where he feeds cattle. He could move that bale of hay to a different part of the field. So that's something that, that's the prerogative of that landowner. We've still got to go back and finish, we did do field 12. We're waiting back for the analysis.